Assalamu alaikum. In this video, we discuss the second part of the chapter, Forms of Energy. Let's recall the objectives that have been discussed in the first part of this chapter. We listed the different forms of energy. We have defined thermal and chemical energy. Also, we have discussed the nuclear energy and the mass energy equivalence. In this video, we discuss the electric energy and its formula and the principle of energy conversion, and finally we talk about the efficiency of a converter. Let's recall the definition of electric energy. Electric energy is an energy derived from electric potential energy and kinetic energy of the moving electric charges. This energy is supplied due to the combination of two physical concepts, electric current and electric potential difference or voltage. The intensity of the current is defined as the flow of electric charge per unit of time. It is given by the formula I equal Q over T, where Q is the quantity of charge in coulombs, T is the time in seconds, and I is the current, and it is expressed in ampere. The electric potential difference, also known as voltage, is the external work needed to bring a charge from one location to another location in an electric field. Its expression is defined as U equal W over Q, where W is the work or the electric energy in joule and U is the voltage in volt. Note that the current is always directed from positive plate to negative plate, and it is opposite to the direction of the electron. The expression of the electric energy becomes equal to W equal U times Q, so it is equal to U times I times T. The power is defined as the amount of energy consumed or supplied per unit of time, so it is equal to energy over time. By substituting W, we have then P is equal to U times I. The power is measured in watt. Note that the electric energy is usually sold in kilowatt hour, and to convert from joule to kilowatt hour and vice versa, we have to use the relation 1 kilowatt hour is equal to 3.6 times 10 power 6 joule. In this application, we have a motor that functions under a voltage U equal to 110 volt. The quantity of charge crossing the motor in 5 minutes is equal to 600 coulombs. In the first question, we have to calculate the intensity of current I. We apply the formula I equal Q over T. I substitute the values and I have to convert from minute to second. So I equals 600 over 5 minutes, which is equal to 300 seconds. So I is 600 over 300, so it is 2 ampere. The second question is to determine the electric power consumed by the motor. We know that P is equal to U times I. Then we substitute and we get P equal to 220 watt. The last question is to calculate the electric energy consumed by the motor during 2 minutes. To find it, I apply the formula W equal power times T. We substitute the values and we make the conversion from minute to second. Then we get the electric energy in 2 minutes, which is equal to 26,400 joules. To convert from joule to kilowatt hour, we have to divide the obtained number by 3.6 times 10 power 6, and we get 0.0073 kilowatt hour. Now we discuss the principle of conversion of energy. The energy is conserved and it cannot be created or destroyed. It transforms from one form to another. And usually for any energy conversion, the thermal energy is produced. Now, what is an energy converter? The energy converter is a device that converts the energy from a form into another one. Herein we list some energy converters. we start by electric motors that convert the electric energy into mechanical energy. And for sure, there is a production of thermal energy. But here we are talking about the received and the useful energy. The dry cell converts the chemical energy into electric energy. However, the resistors converts the electric energy into thermal energy. So the resistors are used in electric heater machines or appliances. The electric pump is used to convert electric energy into gravitational potential energy in order to raise up the water. The natural converter, photosynthesis, converts the radiant energy arises from sun into chemical energy. The turbine alternator system is a well-known system in the production of electricity in different power stations. It converts the kinetic energy into electric energy. The renewable power station based on wind energy uses windmill to convert the wind energy into electric energy. And as in Karaun power station in Lebanon, the hydraulic power station converts the gravitational potential energy of the stored water at a certain height to electric energy. Another important converter that used widely in recent years is the solar cell. This cell converts the radiant energy to electric energy. Also, an important converter is used to heat water. This converter is called solar panel, and it converts the radiant energy of sun into thermal energy. During energy conversion and due to loss in energy caused by the production of thermal energy, it's very important to define efficiency of a converter. The efficiency represents the performance of a converter. In other meaning, if the efficiency is high, it means that the lost energy is low. The expression of the efficiency is defined as the ratio of the energy furnished or produced to the energy received. To find the efficiency in percentage, we have to multiply by 100. Note that the received energy is equal to energy furnished plus energy lost. The energy received is equal to energy furnished plus energy lost, which is usually heat or thermal energy. To practice on this objective, let's solve the following application. We have a system formed of a solar cell and electric pump. We use the pump to raise up the water from depths of 2 meters. The amount of the raised water during time t has mass m equal 10 kg. The definition of the efficiency is given and the resistive forces are neglected. In the first question, we have to indicate the energies furnished and received by the solar cell and the electric pump. To simplify this problem, let's draw a schema that represents the system that we have. The energy received by the solar cell is radiant and the furnished is electric. However, the energy received by the pump is the electric energy and the furnished is the gravitational potential energy because we have to raise water for a certain height. In part A of question number 2, we have to calculate the work done by the weight during the time t. We apply the expression of the work done by the weight. We know that W of mg is equal to mg times initial height minus final height. We make the substitution and we get W equal minus 200 joule. In part B of this equation, we have to calculate the energy furnished by the pump during time t. The energy furnished is the gravitational potential energy, which is equal to absolute value of the work done by the weight. So the energy furnished is 200 joule. In equation 3, we have to determine the energy received by the pump during the time t, knowing that the efficiency of the pump is 80%. We apply the rule of efficiency. The efficiency is equal to the ratio of the energy furnished over the energy received. Then the energy received is equal to the energy furnished over the efficiency. We make the substitution and we get 250 joule. In question number 4, the energy received by the cell during time t is 2500 joule. In first part of this question, we have to give the name of one form of energy lost in the cell. The answer is very simple. Thermal energy is a form of lost energy. In the second part of the question, we have to calculate the efficiency of the cell. I apply the formula of the efficiency. The energy furnished is the electric energy, and the energy received is the radiant energy. I substitute the values, and we get 0.1, which is equivalent to 10%. In other meaning, 90% of the energy received by the cell is lost. In the last question, we have to calculate the efficiency of the system S by specifying the energy furnished and received by the system. The energy received by the system is radiant energy, and the energy furnished by the system is the gravitational potential energy. I apply the efficiency rule to the system, I substitute, and the efficiency of the system is equal to 0.08, which is equivalent to 8%. At the end, let's summarize the main points that have been discussed in this video. The electric energy is the energy derived from electric potential energy or kinetic energy of the moving charges. The expression of the current is Q over time, where Q is the quantity of charges. The expression of the potential difference U is equal to the electric energy over quantity of charge Q. The formula of the electric energy is W equal U times I times T, and the expression of the power is W over T. The energy is neither created nor destroyed. It converts from a form into another, accompanied with thermal energy. The energy converter is a device that converts energy from a form into another one. The efficiency of a given system is defined as the ratio of the energy furnished to the energy received. Please watch well this video and make a short summary for the main rules and the main points. Also, don't hesitate to ask your teacher for any further information, and please do all the recommended assignment. Wassalamu alaikum wa rahmatullahi wa barakatuh.